early days of development of sciences, acids and bases were the most useful concepts, for they described many substances around us, and our understanding of acids and bases until the late 19th century was essentially that acids are sour in taste, bases are bitter, acids turn blue litmus into red. It turns them to red. And bases turn red litmus, whether solution or paper, to blue. And there were some other plant pigments, but that was all fundamentally acids and bases were defined to be, even though they described many substances that we live with. And also, and the limited reactions that we had between acids and bases was that they combined to form salts. So acids and bases combine to form salts. And by the end of the 19th century, there comes a scientist named Arrhenius, Svante August Arrhenius. And Arrhenius was working on a theory of electrolytic dissociation. So let me write down that word, electrolytic dissociation, and that basically that you can regard it as the separation of charged particles. Let's just work with that. And what he said is, okay, let's define acids and bases as acids as substances that produce H plus ions. Let me remove the brackets for now. H plus ions in water. And bases as the ones that produce OH minus ions, or as you would see them, H plus are called as hydronium ions if they are represented as H3O plus, or H plus is plainly called as protons, since if you remove an electron from H to form H plus, you are just leaving yourselves with a proton. And OH minus is called as a hydroxide. And by writing in water, what I meant is that till that time, most of the acid-base reactions that we were doing were based on reactions in the solvent, in the universal solvent, that's water. And we will cover other definitions of acids and base, other extensions of it, regarding the fact that not all reactions take place in water, even though a significant majority of them do. Chemistry has developed really far from that time. But still, Arrhenius' theory is really useful to describe the common things that we have. So let's take something as simple as vinegar. And vinegar is made up of something that we call as acetic acid. And let's forget for now that it's even an acid. Let's just take the chemical formula for vinegar, and vinegar has the following chemical formula. So it's an organic compound. So CH3 on one side and then C double bond OH here. It's something that you would learn as calling carboxylic acid. It's in fact called ethanoic acid. But for now, let's just consider that this entire molecule disintegrates into H plus ions. And since you remove this H from here, you remove the H from the OH, then you are left with, since you take away a plus sign here, you also have to give a negative sign on the oxygen. So you have something that we call as a radical. So this ion containing the O minus and the H plus is essentially the result of the dissociation of acetic acid or vinegar. And you can write a single arrow to represent that, but you'll learn that in the few next videos that representing it with a single arrow is not the best description of what happens. You actually do a double arrow in cases like this. And even before you ask a question that what does this mean, let's just take some acids that completely dissociate. So for now, just take my word that this just means that there is no complete dissociation. There is an incomplete dissociation, and sometimes the products in fact combine to form the reactants, and let's not regard that fact for now. Let's look at something that almost dissociates completely. Let's look at a molecule called HCl, hydrogen chloride. Now, hydrogen chloride has a H, and that dissociates. When that dissociates, you get an almost 100% dissociation. So you get H plus, and since you leave with a plus sign, you also leave with a negative. You also leave a negative sign on the remaining stuff. So you have H plus plus Cl minus. And what that means, if you have 12 dozen HCl molecules, you have 12 dozen protons and 12 dozen chloride ions. And this is something that's known as hydrogen chloride, but you would see it by many names, most common in laboratory chemistry being hydrochloric acid. Hydrochloric acid. You also can do the same for bases. For bases, you have, and notice that this is all happening in water, So either you write H plus, or in the cases, let's take another example. Let's take something just similar to HCl. So let's take HBr. So hydrogen bromide or hydrobromic acid. In this case, in the case of HBr, if you add in the water in this reaction, what happens is essentially you get H3O plus plus Br minus. So the difference between this reaction of HCl and this reaction of hydrogen bromide, except for the fact that there is a Cl here and a Br here, is that you have added in water, and it doesn't make a significant difference, since representing H plus or H3O plus is almost considered equivalent in chemistry, so you can do either. So whenever you are using Arrhenius this definition, remember that you are taking things to be in water. You can do the same for bases as well. So if you have one of the most commonly used bases, one of the most commonly read bases, not used, I can say. So sodium hydroxide, it has immense uses in practical chemistry, in industrial chemistry as well. And when it dissociates, it leaves with an OH minus. That's the hydroxide ion that we were talking about. And since it leaves with a negative sign, it also has to give a positive sign to maintain that neutrality of charge. So NaOH, sodium hydroxide, dissociates into hydroxide ion and sodium cations. And you could just continue doing that for all the substances, but then you'd realize that water isn't the only solvent that you have, and you need a more general sort of representation of what substances can be regarded as acids and base. So that's a general introduction to the Arrhenius' theory of acids and base. Just remember it like this: acids produce the H plus ion, the proton, and bases produce the OH minus ions. So that's the summary of the video. We will meet in the next video, and we will continue talking about acids and base, how to measure them quantitatively. We'll learn about the pH, the pOH, and other bunch of cool stuffs. See you in the next video.